In this question, we're asked to find the Taylor series for x cubed, the natural log of x, in ascending powers of x minus 1 up to and including the term in x minus 1 to the fourth. And then in part B it says, using your series in A, find an approximation for the natural log of 1.5, given your answer to 4 decimal places. Okay, let's just consider the following. What we need now is the Taylor series, and we'll use the form f of x is going to be equal to the f of A plus f dashed of A multiplied by x minus A plus f double dashed of A multiplied by x minus A all squared over 2 factorial, and so on and so forth. And then we'll have the half derivative, and then we'll have now x minus A to the power of r over r factorial, and so on. And this is what we've been introduced to. So in our case, we've got A is equal to 1, so we can say that the f of x will be equal to the f of 1 plus f dashed of 1, and then multiplied by x minus 1, plus f double dashed of 1, x minus 1 all squared over 2 factorial, and we're going to be going up to x to the fourth, so we'll have plus f triple dashed now of 1, x minus 1 all cubed over 3 factorial, and then we'll have plus the fourth derivative, and then we'll have x minus 1 to the fourth all over 4 factorial, and so on and so forth. So this is what we're going to interest ourselves in. We're going to look now at expanding in powers of x minus 1 up to and including x minus 1 to the fourth. Now, if we look at what we've got here, we've got the f of x is equal to x cubed, the natural log of x. So we can now say that the f of x is equal to x cubed, the natural log of x, and that's a product. So we need to find the first 4 derivatives. We need f dashed of x. I'm going to quickly differentiate this. You take your time. If you want to start there, just go up to f and take the 4th derivative. So what we'll have then is x cubed, 3x squared, then we'll have the natural log of x and 1 over x. So I'm going to have now 3x squared, the natural log of x, plus, and then that's going to give me now 3x squared. So that's going to give me x squared, isn't it? This is not a lesson in differentiation. You use your method to do this, so we're going to end up with x squared. Differentiating again, f double dash of x, we're going to end up now with, what's that going to be, 3x squared, 6x, ln of x, 1 over x. So we're going to have now 6x for natural log of x, plus, now that's going to give me 3x, and then we're going to have plus 2x, which of course we can write as 5x. So let's put that on. If you're there before me, I'm sure you can wait up and I'll get it sorted. Third derivative now, what we're going to have is 6x, then we'll have 6, we'll have a natural log of x, 1 over x. So we're going to have now 6 ln of x plus 6, and then this one plus 11. And then the 4th derivative, we're simply going to have 6 over x. So there we go, there are your 4 derivatives now, and we can start building these up. So there we go. We found the f of x, f dashed, right up to the 4th derivative. Now what we need to do is evaluate the f of 1. So if we evaluate the f of 1, we're going to now get, this is going to be 1 cubed, the natural log of 1. The natural log of 1 is 0, so that's just 0. If we now evaluate f dashed of 1, we're going to end up with 3 lots of 1 squared, the natural log of 1, plus 1 squared. Again, all of this here is going to be 0, and we end up with just 1 at the end. Second derivative, evaluating f double dash of 1, we're going to get 6 lots of 1 multiplied by the natural log of 1 plus 5 lots of 1, which of course is just going to give us 5, as this is all 0. The third derivative, we're going to end up now with 6 lots of a natural log of 1 plus 11, quite clearly 11. And then the 4th derivative, we're going to end up simply with 6 over 1, which is going to give us 6. So there we go, some quick, I'm kind of assuming that you're going to be cool with that. So what we can now do is simply say that x cubed for nat log of x is going to be approximately equal to the f of 1. The f of 1 is 0, plus f dash of 1 multiplied by x minus 1. That's simply going to give me x minus 1, as my f dash of 1 is 1. Then we want the next one, so we're going to have plus 5 lots of x minus 1 all squared over 2 factorial. 2 factorial is 2, so we get 5 over 2x minus 1 all squared. Then the next one, we're going to have plus 11 multiplied by x minus 1 all cubed over 3 factorial, which is 6. So we get 11 over 6x minus 1 cubed. And then we're going to get 6 x minus 1 to the 4th over 4 factorial. 4 factorial is 24. 6 over 24 is going to give us 1 over 4. You'll want to show your full workings in an exam. I haven't, purely based on the time and the space. So we can say that now x cubed, the natural log of x, is approximately equal to, and we can get rid of that 0. Or you could write this now, that x cubed, the natural log of x, is equal to x minus 1 plus 5 over 2 x minus 1 squared plus 11 over 6 x minus 1 cubed plus 1 over 4 x minus 1 to the 4th, don't want that, do I? Don't need another bracket. X minus 1 to the 4th, so on and so forth. That's a bit heavy-handed, wasn't it? Let's get rid of that. Certainly didn't want to do that. You can see what's going to happen, isn't it? That's just going to be x minus 1 to the 4th. So let's do that there, and so on and so forth. Okay, that's done. What we now need to do, let's see what we've got on the next part. We've got to, using your series in A, find an approximation for the natural log of 1.5, given your answer to 4 decimal places. Okay, we need to be a bit careful here because we've also got this x cubed here. So if we consider we're doing now, x is going to be 1.5. So we're going to have 1.5 here, cubed, the natural log of 1.5. Consider subbing in x is 1.5 here. All we're going to get is 0.5 plus 5 over 2, 0.5 squared, plus 11 over 6, 0.5 cubed, plus 1 over 4, 0.5 to the power 4. And this now, we can just simply expand and then divide through. So if you want to, what you could do now is, in the calculator, you could write, and I'll write this, in fact, let's put in our answer. So our answer is going to be 0.5. Okay, so we'll put that in as our answer. And what I'll do, I'll write 1 over, and then we'll have 1.5 cubed, and then we'll multiply this now by my expansion. And my expansion, let's get out of there. Hopefully you can see what I'm doing. I'm dividing through by that, but I kind of want to set this slightly apart. So let's just consider now what we've got here. This is the first bit. So we've got my answer, and then what we're going to have now is plus, and then we're going to have 5 times my answer squared over 2. Okay, and then on the next one, what we're going to have is plus 11 times my answer cubed. So we've got 11 times by my answer cubed, and then that's going to be over 6. If you don't want to simplify these and just write them as the factorials, you're more than welcome. The factorial button's just there. So on the next one, what we had now was plus, and then we've got our answer to the 4th, and this is now over 4. So, for example, if you wanted to, what you could have done is with this one, you could have used the factorial and put the 6 up in here, because that's what it was before. Remember, this was 6 over 4 factorial. This will do exactly the same. But if you don't want to, you can go back. Okay, let's get rid of that factorial, so that will change my answer. And there we go, this is what we wind up with. So we've got now this, okay? So there we go, that's all the bits and bobs. That looks all pretty good to me. And then all we need to do is evaluate this. And now, let's just check I've got all that. Yeah, that's good to go. And then this gives us now 263 over that. So we're going to get now 4058. So what do we get? 4058641, was it? Don't know how many I stuck in my head. 1974. So let's now see if that's good. That looks pretty good. Okay, so what we need to do now is round this to 4 decimal places. So what we're going to get, we're going to 0, and what's that going to be? 59. Okay, so we can say that that value now, we can say to 4 decimal places is the natural log of 1.5 is going to be correct 4 decimal places of this answer. If we now look at it, what we can see now is the natural log of 1.5. Let's see what we actually get now. And you can see at this point right here, natural log of 1.5, we can see that they've got 0.4, 0546 and so on and so forth. So if we look at ours, you know, it's not too bad, but hopefully that gives you some idea. And do remember that this is an approximation, okay? It is based on what we've expanded. We can see quite clearly the real value is here, but this is an approximation. So there we go, we've gone through it fairly quickly. All the derivatives, I'm kind of letting you go for those. But this is the essential take-home message. And the killer one with this was not to divide out by the 1.5 cubed right here.